section before we actually do the EOC. Will be the only other test that's going to be going in. Okay, so this section, when Carter talked about it in his video, because I don't teach calculus, he said this is probably one of the most important things. If you had 1 out of 10 for calculus to know how to do, this would be one of those. Okay, we obviously do more than just test objectives, but this would be probably one of your top ones. Okay, I actually think this is just as easy as the last section. So if you thought the last section was easy, then we should be skating into summertime, not stressing about math. Okay. Okay, I just saw some smiles, yay. Okay, so compositions of two functions. So the word composition means that you are plugging equations into other equations. Are we good? Like, guys? Okay, composition means you're plugging something in. Okay, so we're going to have two functions. We've done this. We've plugged in for x, and you get a, what have we been doing? We plug in an x and get a what? She's laughing. A y. Okay, so we've been doing that. We're going to be doing the same thing on this section. Okay, we're going to be plugging in a value for a variable and getting an answer for another variable, and that's all it is. But it's a little bit different because you're plugging an equation into an equation versus plugging a number in. Okay, so here we go. Okay, and then inverse. Inverse is 107. What does inverse mean? It's not a new word.
Not direct. Right?
Close. If I say let's add, and I want you to do the inverse of that, you would what? Subtract. So inverse just means to do the opposite, right? Undo what I just did. Okay, do the opposite. Okay, so that's going to be what 107 is. Okay, so starting on. Okay, so composition, we're doing the first one, 106. Okay, so composition, the definition of composition is putting one function into another function. Okay, and then this is an example of what one could look like. Okay, we put x squared in for what's being cubed. We've done that before. That's not what we're doing in this section. Okay, I don't need you to write the answer to this, but I want you to say it. So we've done this in algebra, and maybe pre-algebra. If I said to simplify this, what would you tell me the answer is? Okay, so just remember that. That's all we're doing is plugging something in and practicing our algebra skills. Okay, so this would be number one. This is what number one looks like. Okay, and it's not any tougher than what we just saw on that board. Okay, so this is number one. I'm sure about that. Yeah, this is. You do this in algebra. We had f of x equals x, and I always say that f of x stands for the what? The y. So you're plugging in a value for x and getting an output for the other one. So it's not, okay, we just now have g and x.
I feel like they're just let's keep all these ones up like this.
Yeah.
No, this one is actually kind of easy if you do it, like if you're again.
Okay, we good?
No.
No, not yet.
Okay.
Okay, now we good? Everybody got it written down? Okay, don't write this. I'm just substituting a number instead of a variable so that it just makes more sense for us because we've been plugging in numbers for x, right? We had our t-bars or graphs that we had when we're plugging in things. And I tell you what an x is and you plug it in and you're able to tell me what a y is, okay? So if I was looking at this, because this is what we're solving right here, okay? This is similar to, don't write this is similar to if I had f of x, right? And I'm given an x value, okay? I could plug it into the equation and I would actually say that that is my y answer because this is an example of y equals, and then we would have the x value on the other side. So whatever I plug in for x, it's actually my answer for y. Okay, and that's what you were doing. So remember when we did the notes, I said you can change f of x to y if you want to. Okay? Well, similar thing here, okay, except now we've got multiple things that we're plugging in. So if I started with just g of x, okay, and it was like this one right here, and I said that we are plugging in the value for x, we're going to plug in 4. Okay, so don't even look at the f equation up here. We're just plugging in 4. Okay, so I go 4 squared, which would be 16, and 16 minus 3 would be 13. Okay. We good so far? Okay. So now it's just doing it again. So you solve for g. Now they're saying what this answer is. Now you're going to plug it into the f of x. So this is my f of x. So whatever answer I got here, now I'm going to take it and I would plug it into there, which would just be rad 13, right? Because we can't simplify that one down. So that's all we're doing. So we start from the middle, okay, and work our way out. So whatever is happening right here, we're going to take that answer after we've plugged it in, okay, and then plug it into the second equation, okay? So right now, we just have an equation. Okay, so now we're going to start to write that. Okay, so I just said we plugged into this one first, right? So I don't have the answer to this. I just know that I'm going to, so I want you to circle it, because that's the one that's in. I always just remember the one that looks like it's in a bunch of circles, that's the one I'm moving, okay? So I'm going to move this into where the x is at and rewrite my equation. That's all I'm doing. I'm not solving it, okay, unless it is solvable, like if there's a number and we can do perfect squares and you solve it. But otherwise, you're just rewriting it, okay? So if I put this in here, I'm replacing the x with x squared minus 3. That is it, okay? Because can we solve that? We could if it was just that, right? Then that would become what? Just x, right? Okay, but we can't solve it any further. So that's all you're doing. That's, you would either rewrite the equation.
That's the answer?
That's your answer.
Oh, wow. That's,
Okay, you don't, when you see the answers or on, when you do the Google form, they'll have this equals and then you write that there. I'm not going to make you rewrite that. Okay, I just want to know what the final answer is. So that's all I'm going to read when you do the answers. Okay? Okay, it actually gets easier as we go along. Okay, so this is number 2. So if we can simplify things down, we simplify it down. Sometimes we don't get as far as you think we should be getting. But. And they just changed variables. So it's not, it's pretty much what we've been doing with f of x all the way along. X's and y's. Good. Okay, so remember I said this kind of looks like it's already like a circle, a bubble, okay? So that is, it's the inner one that we move first, okay? So I'm going to move this one first, and I'm going to put it into the other equation where the what is at, x. Okay, so I'm replacing it, and I'm going to rewrite this equation, okay, and put that in that spot. So since that 2 is here, we're going to have to do a little bit of simplification. You don't just write the equation. If there's anything that you can multiply out, then I'm going to do that. Okay? So I'm just rewriting it. So it's 1 over 2, and I'm replacing the x with what is up there, which is x plus 4. And then writing the rest of my equation. Okay, this one we can simplify down, unlike the last one we couldn't. Okay? So if I distribute, I'd have 1 over 2x plus 8 minus 3. there any more I can simplify? Okay, that's great. Okay, so my final answer would be 2x plus what? 5. So that would be what would be written after the r of h of x equals that. Okay. Still easy? Okay. Okay, let's see if you can do this one. At least try, because you can always fix it. And I'm not going to call out anybody. This one actually should be easier than the ones we did there. So this is 3, right? I don't have a number to say. Yes. So you're actually going to plug a value. No, if you can do it in your head. Okay, so this one works out all the way down where everything is gone. Okay, so if I'm plugging in 4 for x, for the h of x, I'm plugging in 4 here, so that means I would put a 4 there. So the square root of 4 is 2. Okay, so really now I'm plugging in 2, not 4, because g now, if you had f of x, this g, this whole thing now became 2. Okay, so now I'm plugging the 2 into this equation there, and then doing the order of operations. So 2 squared would be 4, and 4 minus 2 would be 2. It happened to be the same answer, but that won't always be that way. Okay, we good? Okay. Try another one. This one actually has a value as well. Okay, what'd you get? 1. The answer is 1. So plugging in 3 first. So 3 minus 1 would be 2. So 4 divided by 2 would make it 2. Okay, and then plugging 2 into here. So 2 times 2 would be 4, and 4 minus 3 would be 1. You will have some that wind up being a fraction. Okay, and then you have to plug in a fraction, so you'll have to get a common denominator for your other ones before you add and subtract. And you do have some, because I went through and did the try it yesterday to make sure. So you'll have some on those today. This one just wound up to be a whole number. Okay, so done with that. Now we're just kind of looking at how we write compositions. Okay, so this would be number 5. We're not doing anything on this. We're just going to talk about this, like the order of which things are done. Okay, this part I think is more pre-calc. Okay, then algebra. I feel like that other one's like super easy, probably more algebra 2 stuff than this. Okay, so when you get to pre-calc, you'll be going the opposite. Okay, so they give us the composition and then we plug it in and solve it. What you're going to be doing when you get, and on some of your worksheets today, is they'll have this and they'll say, what is the order? So they might have these two right here, okay? But you're writing a composition. So composition, kind of like we think about music, you're writing the steps of how you get there to put it all together, okay? So we had the steps and put it together to get to the final thing, okay? This one is this, and then you have to figure out which one went first, okay? So which one of these, if you're paying attention to the right-hand side, which one do you actually have to have first? Is it the order that it's in or the opposite? It's the opposite. So when you're writing a composition, you want to think about, what can I write? Okay, what can I write to get this on the bottom? Okay, so this would be this part first, right? So it really goes backwards from where you want it at. Okay, when we plug it in, we work this way, right? We do this part first and come out. When you're writing the composition, you go this way, okay? So this would be 1 over an unknown, okay? And so we have 1 over the unknown. And then we're writing, so this one would be our first step, okay? And then our second step would be, okay, now what am I gonna plug into this unknown? And that's where this one came from, right? Which is opposite of what we did. We took this one and then plugged it into that one. Okay, so the order is opposite of the way that you write it. Okay, so then when you go to write this is the actual composition or the order of which you would do things in, okay, then you would write it as, we want to finish out with this, right? But this is the part that we're going to plug into that. Okay, so that one was done for you. I think all of these are done for you actually. Except we don't know the order. Okay, we're going to write the order in this one. Okay, so this is number, I stopped writing, 6. Okay, so this is how we want to end up. This is our final answer. Those are the 2 parts. I just need to know which one is written first and then which one is written second, which would be in all those parentheses to get to that. Is G written first or is F written first? G, right? Okay, we would start with this one, right? Because we'd have this, and I would need to say, okay, what do I need to plug in and replace X with? I would plug this in, right? Okay, so when we go to write it, we need G, right? Okay, so we're going to have parentheses, and then you'll have your F of X. Okay, so G was first, so it's first, and then this, but when we actually solve it, we take this, and then plug it into that. So we work inside parentheses going out when we actually do it. But when we write the composition, it's backwards. Okay, so that was number 6. Okay, this is not a problem, you're just writing this. So that you know you're going to see it 2 different ways. And this actually, just because I blew it up, it looks bigger. It's really a tiny 0, almost looks like a degree symbol, so don't make it big where it looks like fog. Okay, it's like a dot, like a multiplication dot. Okay. Okay, so the only reason why I'm having you write this is both of those things mean the same thing. Okay, so not that you're going to remember names, but way back in, I don't know, 16th, 15th century, I don't know what it was, when all these math geniuses started coming up with all these things because they thought you needed to know this. One created the order of how we plug things in and wrote it one way, which was like Newton was one of them and Lighton was the other one, okay? The other one discovered it and actually got it documented that, hey, I'm the one who discovered it. but the person before it actually had it and had the information out there, but never like documented it. Okay. So when you get on the web, sometimes you'll see it written one way, and they have them both out there because they both actually came up with it a long time ago. Not that you need to remember that. Okay. So it kind of goes back and forth on the worksheets that it looks like that. Okay, so I just, anytime I see it, because I'm so used to this one, it's usually the one, because we usually have just f of x with parentheses, not a little dot looking thing. Okay, I just replace it, just get rid of it, because that now it looks like that one, okay? But it means the same thing. Sometimes we hear f of, like that O, they stands for of. Of also means times, okay? Which parentheses inside of parentheses is times, okay? Did you? Okay. So I just wanted you to have the two different notations. So if you come across it, you're like, oh, what's this? Looks different. It's not. It means the same thing. Okay. I don't know if we need to, yeah, one last one. And this is just because it's written weird. And then we'll go to 107. Okay, what'd you get? 1/5. I need to do that one? Anybody not get it? Okay. All right. Moving on to 107. So inverse function is the actual vocab word. So inverse function, it's an opposite operation function. Opposite operation function. And then I'm scooting it down. Inverse functions undo each other. So like when we talked about adding, the opposite to undo it would be to subtract. Multiply would be divide. Square, square root. Good. Okay, so proper notation. Okay, so on the left-hand side, this would be our regular f of x. Okay, so if you were asked and you had this as your problem and they asked you to write the inverse operation, this is the symbol that means inverse operation. It's got a -1 as an exponent. It just means what is the opposite to undo that. Okay. And we already talked about it, that adding, opposite of adding would be to subtract from your x. So if I said x was 5, I'd go 5 plus 2 gives me 7. Okay, if I take my 7 and plug it into here, 7 minus 2 gets me back to my original, which was 5. Okay, so we're undoing the operation to get back to the original. Okay, so and then for 2 times x would be x divided by 2. And then the square, so like if I plugged in 16 here, or not 16, I just said the answer. 4, so if I square 4, I'd get 16. If I plug 16 into here, it gets me back to 4. Okay, so all of those undo and get you back to the original. Okay, so just to have an example, it's not a problem we're doing. Write this one. And then we'll actually go to the problem. And I still don't know. Okay, so we need to get back to the original. So in some of these you will have to check and it'll ask you, is this an inverse operation? Is it a function of it? So in order for it to be a function, the inverse operation, you have to be able to get back to the original, okay? So if I plugged in a 5 here, squaring 5 would give me 25. So I take that answer and I plug it into here. Well, the square root of 25 got me back to 5. So whatever we started with, we have to be able to get back to. Okay, and if it doesn't, then it's not a function of those equations, the inverse operation. Okay, first one, so this is number 8. Okay, this is how you will see it on the worksheet. I've already told you you could leave it like that, or you can rewrite it, because f of x means the same thing as y. Whatever I'm plugging in for x, I'm going to get a different answer, right? So it's a different variable, okay? And some of ours that we had in the previous were g and h and f, and okay, you're just going to get a half different variable. Good so far? Okay, so to make this as simple as possible, all you're doing is flipping your equation to solve for the other variable, because the way that it's set up right now, it's y equals, right? Okay, so to write our information, we're going to flip it and get x by itself. Okay, so if I want to get x by itself, no. To get x by itself, okay, I've got to move this over to the other side, right? So I do the opposite, which would be subtract 2. So now I have y minus 2 equals x. I'm still not sure about that. Don't like that. Okay, we good? Okay, so when we go to write our operation now, we're going to take what has been moved and we're going to change that variable back to x, because they want to know what is the opposite. Okay, we don't want y, we're solving for f of x, the opposite of x. Okay. So when we go to write our answer, I'm writing this as the -1, because I'm saying this is the opposite of the original, because this was the original, right? So now I'm writing the opposite of the original. Okay, so now I'm going to have x here. And I'm just rewriting this, but get rid of that y, because we want to know what the x is that we're plugging in to get the y. Okay, so we're going to replace this with x. Okay, and write this as x times. That's it. That's all we're doing. Okay. This is number 9. And we are going to write okay. So I'm just replacing this. Some of you will be able to do these in your head. Good class of these. Okay. I want to solve for x. So to solve for x, my first step would be to move the 4 over to the other side, right? So then it becomes y plus 4 equals 3x. To get the x by itself, I need to what? Divide by 3. So divide by 3, but I got to divide everything over here by 3. Okay, when we go to write this as the opposite, I'm not going to write y here. I'm going to put a x. So it's x plus
For our answer, do you want us to write that to the negative?
yes, yeah, on this one. Okay, so let's try something. So if I plug in into that first equation, okay, the f of x, not the opposite one. If I plug in 5, 3 times 5 is 15, and 15 minus 4 is 11. Okay, so now if I go to plug in 11 to the right side and go 11 plus 4, I get divided by 3, got me back to the original. Okay, so a common mistake on, I'm just gonna write it out, what is that? Is people will move one thing, like they'll move this over, so they'll have y plus 4, okay? But then when they move this, they'll only have over 3 over here. Like they'll do the opposite of this one, but just move that one over. Because really when this is by itself, this is times, opposite is divide. And so they kept it separate and then moved the 4 over. Because they know they should have a divide one and then an opposite of that one, which would be an add one, okay? Which that would work, because if I plugged in 5 here, we said it came out to be 11, right?
Yeah.
Yeah. So then if I had 11 over 3 plus 4, is that going to get me back to 5? No, because then I'd have to find a common denominator, and it does not work out, okay? So plugging in any value, you have to be able to get back to the original, okay? So that first one would be written, okay, if people separated those and not know the order of operations. Okay, number 10. Last one. Okay, so getting y on the side. Okay, first step is to, nope, the 5. Okay, so order of operations, if we actually plugged in, right, we would subtract and then square it and then times it by 5. Okay, so it's the opposite. You go this and then over the other way when you're actually rewriting it. Okay, so when I divide by 5, I'm going to divide by 5. Okay, so that goes away. So now I have x minus 3 that's being squared, and then y over 5. Now what do I gotta do? Square root it, right? Because I can't just simplify this. I gotta take care of this and then do that. Okay, so I'm gonna take square root of that. When I take the square root, I'm taking the square root of everything. So you can write one big square if you want to, okay? But we learned when we take the square root of something, the potential that comes out of it could be positive or negative, okay? So we're gonna have, just for right now, we're gonna put this, because neither one of those are perfect squares, okay? Equals x minus 3. Okay, last step to get x by itself. Add 3, right? Okay, so we can just put it in the front because it's a plus 3, right? Okay, now typical, it's not okay to have a radical in the denominator. So on the answer key though, they left it like this. Okay, it's not proper, it's not simplified all the way, but we would go rad 5 times rad 5, so you'd have rad 5y over the top of 5, right? Because it would be 25 squared 25 over 5. So just for future test taking, this is not simplified. Okay, so when we go to write it, we'd have the f of negative 1 with x and then 3 plus or minus, but under that rad, it's not a y, it's a x, okay, over rad 5. Okay, now, these are the ones that they like to say, is it a function? They want to know if the inverse is a function. Okay, so in order to be a function, it means you have to be able to get back to the original. One input's going to get one output, okay, but you have to be able to get back to the original. Why would this one not get me back to the original?
Because you're gonna have two different answers.
You're going to have two different answers, right? On this, I could have a positive something and a negative something, okay? So it's not going to get me back to the original because it's going to be two different answers. So anytime you have this guy and they ask that question, the answer is going to be no. Okay, functions mean a one-to-one thing. I'm going to plug in one thing, get one thing as an answer. Okay, this would be plugging in something into the original, but down here getting two different answers. So it's not a function. So you'll just say no. Okay. Yes. You would write that as the answer because that is the inverse. But then they ask the second question, is it a function of the inverse? And the answer is no, because function means one-to-one. Okay, that is it. Okay, let's see if you think this is just as easy as the last.
So you write it as like F. So
Yeah.
One.
Yeah.
X. Okay.
Of x, you'd have 3 plus or minus, and then 3x over. I know, and look at the dots, how big they are. It looks like an O. I know. Yeah, they're not supposed to.
Where